Hi, everyone, and welcome to Unlocking Technological Innovation with Octavia Carbon. I'm Brynn Esterly, CDR Projects Manager here at Climate Vault. If you're new to Climate Vault, we help organizations measure, manage, and take action on their carbon footprint in the most credible and verifiable way possible. Our integrated reduction and removal program utilizes government-regulated compliance carbon markets to generate the environmental impact that today's employees, stakeholders, and customers care about and expect from organizations. Our first of its kind methodology will then leverage the value of those emission allowances from the compliance markets to stimulate the growth and development of carbon dioxide removal technologies. We assess and select innovative CDR technologies, excuse me, through our annual RFP program, identifying solutions that can make a meaningful impact in the fight against climate change. Today, I'm joined by Professor Daniel Schrag. Dan is a professor of geology at Harvard University and is a member of Climate Vault's esteemed Technology Experts Chamber. Welcome, Dan, and thanks for joining.
Nice to be here.
Joining us as well is Martin Freimuller, co-founder and CEO at Octavia Carbon, the Global South's first direct air capture company based in Nairobi, Kenya. Octavia is one of the two winners from our latest RFP cycle. This is the first time that the Tech Chamber has selected applicants that meet their rigorous standards for high-quality, scalable CDR solutions. Congratulations, Martin, to you and your team, and welcome.
Thank you so much. It's a pleasure.
Thank you both. Really excited for today's discussion, so let's dive right in. Dan, you have extensive experience in geochemistry, climatology, carbon capture and storage, and energy policy. So I'd love to hear from you. What excites you most about CDR, and also why can it be so challenging?
Well, we're still in the early stages of the energy transition, trying to get fossil carbon out of our economy, ultimately eliminating CO2 emissions to the atmosphere. And as part of that portfolio, we need things like renewable energy, we need energy storage, but many experts believe that getting to a net zero economy is going to require removing some CO2 from the atmosphere, because there will be certain parts of the world or certain types of technologies that will be extremely expensive to decarbonize. And so we're going to need to remove carbon as well. And the scale of that requirement is probably enormous. It's early days, so we don't know for sure, but it's probably billions of tons of CO2 per year. And at this early stage, what's exciting is there are many different ideas for how to do that. And so what Climate Vault is trying to do is figure out what those best technologies are right now and nurture them along through supporting their work.
Great, thanks, Dan. And now, Martin, as the Global South's first DAC company based in Nairobi, Kenya, I hear your origin story started around a kitchen table one night in June of 2022. So I'd love for you to take us back to that moment. Can you tell us a little bit more about it?
Yeah, no, perfectly happy to. So the initial background was that I used to be based in London and was in consulting and working on a topic that really caught my attention, which was how to create millions of fully livelihoods across the African continent. And knowing that carbon removal had to be a large industry, very much building on what Dan just shared, I knew that this had to be ultimately a large livelihoods driver as well. And over time, I realized that Kenya is the world's best place for data capture and moved my life there. And independently, my co-founder, Duncan Kariuki, was home during the pandemic and during the pretty much worst drought that has hit Kenya in a long time. And so he's an engineer, and as part of his mechanical engineering final year project, he thought about building a data capture pilot. And ultimately, we found each other on an online community called Open Air Collective. And from there, really, we connected and really started bouncing ideas around. And ultimately, that's what gave rise to Octavia Carbon. And we started out in earnest in June 2022 as 3 people on a kitchen table. And today there is 60 of us. So it is very much exciting. And yeah, I think it's been a very exciting 2 years.
Very exciting. Thanks for sharing, Martin. It is incredible to see how far you and the team have come in just about 2 years' time. I have to ask, I know this is something we've spoken about before, and as an avid runner and marathoner myself, I did notice that Octavia, at your pilot facility, you have a really cool mural on your wall of Eliud Kipchoge, who is the greatest marathon runner of all time. He's also from Kenya. Can you tell me a little bit about the meaning of that mural and how Kipchoge has inspired you and your team?
Yes, of course. So when we look at the rate of our progress over the past years, we often say that nobody runs as fast as Kenyans. And that is objectively true. As you say, Eliud Kipchoge is very much the fastest man on earth. And the thing he has done, which he's very well known for, is he's the first human being to run a marathon in less than 2 hours, a remarkable achievement, and one that really defied, physics and biology the way that many people would have described it, even just 20, 30 years ago. Again, people used to write academic articles all about how nobody would ever feasibly break a 2 hour marathon time. People ultimately have done it. And that is part of what motivates us. Sort of the number that is next to that marathon time on our wall next to the mural is less than $100 per ton. Because that is very much the sort of moonshot target costs that we want to hit for that air capture to really scale, to really hit the climate relevant sort of sphere that we wanted to reach. And Kenya is a very key part of that ingredient, basically, because of that journey, because we have, again, uniquely low-cost renewable energy, and especially geothermal, that we can really leverage to bring the cost of direct air capture way down and really replicating many of the past climate tech miracles and cost curves that we've seen for solar, EVs, for batteries, and now the plan is for direct air capture.
Well, thank you. I appreciate you sharing that with us. Now I'd love to dive right into the technology itself. Martin, can you please describe for us Project Hummingbird, which is Octavia's pilot DAC and storage plant that you're developing in Kenya, and tell us a little bit about how it works?
Of course. So just as a very, very quick primer on direct air capture. So essentially what it is it's a CO2 selective filter inside a machine that we expose to air, then we're using a fan. And once that filter is saturated, we close off that system, heat that filter, and then that releases the CO2, which we can then sort of select, process, and ultimately pump underground where it turns into rock in a number of months to years. And that is a quite unique and novel approach globally. It's been piloted elsewhere, notably in Iceland. Our unique approach to that really uses, to sort of those who might be a bit more informed on the topic, amine-based solid solvent direct air capture technology, and really seeks to leverage low-grade geothermal heat in quite unique ways to really drive direct air capture down the cost curve. Elements of which have been demonstrated in Iceland before, but we really seek to integrate uniquely well with Kenya's geothermal, which has been growing very fast over the last couple of years, really, growing fourfold over the past decade, which makes it really a standout in the global geothermal space, where geothermal, for the most part, has been a stagnant or declining resource. And again, with Kenya, we can leverage that quite uniquely to bring both their air capture, ultimately also geothermal, down the cost curve.
Great, thank you so much. And you mentioned the geothermal component. We're definitely going to dive further into that later in this webinar. But first, I wanted to switch to Dan for a second. So Climate Vault received several proposals for DAC technologies in our latest RFP round. So I'd love to hear from you. What made Octavia's approach stand out to you and to the tech chamber?
Well, a couple of things, I think. First of all, within the broad spectrum of carbon dioxide removal technologies and approaches, there is a special category which is called direct air capture. And Octavia is trying to do that. And right now, so the distinction is that there are many different ways of removing carbon from the atmosphere. For example, you could plant trees and then harvest the carbon and store them underground or somewhere. There are a variety of other approaches to removing carbon, but direct air capture really refers to physically or chemically removing carbon dioxide from the atmosphere with some industrial process. And again, right now, that technology is very expensive, but we're in the early stages of development. And so it's really important to see how we can push that technology forward. The reason that there's some advantage of direct air capture is that it avoids some of the challenges of other forms of carbon dioxide removal. When you're removing CO2 from the atmosphere, you start with air and you end up with a concentrated volume of CO2 that you then put in a storage facility. It's easy to verify, and that you've actually done it. And so there's something very straightforward about it. Again, whether this technology takes off or whether it's broadly used around the world is a separate issue. But I think looking at credible forms of direct air capture is really important. More specifically about Octavia, I think there were two things that stood out to me. Number one, they're using a process that essentially a chemical that absorbs CO2 from the atmosphere, but then to release that CO2 requires some heat. And that's true for all forms of direct air capture that use this kind of sorption approach. What's exciting about Octavia is that their process appears to use waste heat. That is, there's a lot of, in industrial processes, a lot of heat is generated. Tends to be hot water that's, maybe between 50 and 100 degrees Celsius. There aren't very many uses of such hot water. And so there's a lot of it around. A lot of times they just put it back into the ocean or into rivers. You can only put so much in because it'll raise the local temperature and that will harm the ecology. What Octavia is doing is using waste heat to regenerate that CO2 to drive it off the chemical that absorbs it from the atmosphere. And that's really exciting because it's done at a relatively modest temperature. And that's really important. The second thing is something Martin already talked about, which is that it's in Kenya. And to me, it's not just that it's in the global south, but to me, it illustrates something that my colleague Ricardo Hausman and I call green growth. And this is the idea that if the world is transitioning towards a more renewable energy system, this is an incredible opportunity for poor countries, developing countries like Kenya, to play a major role and ultimately an opportunity for them to experience economic growth. Traditionally, decarbonization is something that's considered expensive. The rich countries have caused the problem by putting most of the CO2 into the atmosphere, and now they're asking developing countries to decarbonize when they actually haven't contributed much to the problem in the first place. Green growth turns that whole framework around, and I think Octavia is a perfect example of this, where a renewable energy system, the fact is, the global south tends to be sunnier, windier, and in some places rich with either hydro or geothermal. In the case of Kenya, they have both. The analogy to Iceland is a very good one. Iceland also has geothermal and hydro. And 50 years ago, Iceland was a relatively poor country of fishermen. And now the world's aluminum industry has moved to Iceland because they have cheap, clean electricity. Well, Kenya has the same opportunity. Kenya stands out in Africa right now as being, in some ways, the most renewable country and the most with relatively inexpensive electricity. That's an economic opportunity for Kenya. And this is just one of many possible opportunities for economic growth, but I think it's really exciting.
Thanks so much, Dan. And I'd love to build on that a little bit further because I know that the Climate Vault Tech Chamber is very focused on when we're assessing different technologies, you're very focused on additionality, leakage, and permanence as criteria for assessing those technologies. And that's also where we've seen a lot of applicants fall short of those standards, not only for this RFP round, but in our prior RFP round. But that's not the case for Octavia, right? So I'd love to hear from you. What gave you confidence in Octavia's ability to meet these standards?
Well, we could get very technical in talking about all of the different components of Octavia's technology and their partner who does the carbon storage. But I think Octavia was successful in making a credible argument for their approach to direct air capture that looked incredibly promising, and coupling it with heat from geothermal in Kenya was incredibly attractive. As I said before, there's an advantage to direct air capture because it tends not to have the problem of additionality. So additionality means, would it have happened anyway? So for example, you can say, well, I'm going to harvest carbon by planting trees. But if you did nothing, would the trees have grown anyway? That's the additionality problem. If I didn't do this, what would have happened? Direct air capture avoids that problem because if you don't capture the CO2 from the air, it's going to stay in the air. There's no question about it. And so in some ways, the direct air capture finesses a lot of these issues. There are still concerns about permanence in terms of where you're going to store the CO2. And we're confident that at this early stage, Octavia has a reasonable solution for this. It's also important to recognize that this is a small scale demonstration. This isn't, a huge commercial scale plant. So we're in the early stages of this technology, but I think it's very exciting to see this move forward.
That's great to hear. Thank you. And you mentioned a few of these components, but I know that when the tech chamber was reviewing this proposal, I believe we'd actually called it a trifecta, right? Because it brings direct air capture to the table. It's taking place in Kenya, and it's leveraging geothermal energy, which makes it quite exciting. So now I'd love to turn our attention towards the geothermal side of things. So Martin, this question's for you. Why are Kenya's natural geothermal capabilities so critical to your technology?
No, great question. And important to stress that if there's one thing that people should know about direct air capture, it is that it is thermodynamically energy intensive. And of course, any energy that you put into the process mustn't emit more CO2 into the atmosphere, because otherwise you're just going 2 steps forward and 1 step back. And that is what makes Kenya incredibly exciting, because for the combination of those renewable sources that Dan had mentioned earlier, our grid today is 93% renewable. In our specific deployment area, the substation literally draws 100% renewable energy from electricity, from geothermal and wind. And that is a very exciting opportunity for something like that capture, and not just on the side of electricity, but also crucially on the side of heat. Because as we've heard a couple of times now, about 85% or so of energy that our process requires is just heat, and specifically renewable heat. And that can be a very, very low cost of renewable energy, especially when you're in geothermal areas, which are almost by definition one of the most concentrated, least carbon emitting, and also lowest cost forms of energy on Earth. And that makes it a very sort of exciting resource to build their air capture around, which uses a lot of that heat directly and can also crucially integrate with existing geothermal plants who reject up to 80% of the heat that they use just as steam. And that is a crucial energy resource that we can use to then also make geothermal much more cost effective in the country and unlock electrification for the rest of Kenya.
Thanks, Martin. Dan, I see you nodding along. Is there anything you'd like to add to that point as well?
No, I think the location of this opportunity is really very well chosen, and I think that is what makes this very exciting.
Great. Well, Martin, I did want to dive a little bit deeper as well, because I do understand that Octavia's use of geothermal waste heat and capacity also has broader positive impacts within Kenya. So do you mind walking us through kind of what are those broader environmental and societal impacts that you see for leveraging geothermal energy in this way within Kenya?
Of course. So important to note that Kenya has made huge strides in connecting its population to the electrical grid. So over the past few decades, we went from something like 15-16% sort of connected to the electricity grid up to 70%. And that within Africa actually makes us one of the leaders. And that is, of course, great, but it still leaves 30% of Kenya's population, mostly in rural areas, not connected to the grid. And of course, we all know the sort of life-changing implications that has. And what we think about in that reference is that one thing that Kenya is missing right now, it's not the renewable resource. It has plenty of that. There's more than 10 gigawatts of geothermal potential, but it does not have the demand for that electricity. And the critical thing there is that any grid on Earth, including in the United States and elsewhere, you need industrial baseload demand to actually cross-subsidize the electrification of rural areas. Rural consumers very rarely pay the full cost of bringing electricity to them. And that is, of course, a key opportunity that we now have in Kenya as well. With an energy-intensive resource like their air capture, pulling energy and then thereby being able to cross-subsidize both the broader electrification of rural areas, or alternatively, the lowering electricity costs for other industries and consumers that are already on the grid. And ultimately, a lot of that is achieved by using waste resources, right? Like currently, there's a lot of waste capacity, about a gigawatt hour a day just goes to waste, because especially at night, there's just no bankable demand for that electricity. There's a lot of waste heat, and as I said, up to 80% of the heat that's used by geothermal power plants gets rejected. And then finally, a lot of waste infrastructure, because not every well that is being drilled is necessarily like effective for power production, but can be repurposed both for direct heat use and then alternatively for the geological storage as well. So there's a lot of like implications for using some of those resources to cross-subsidize electrification and lower cost electricity elsewhere.
Great, thank you. And Dan, I'd love to hear your perspective as well. What do you see as the significance of Octavia leveraging geothermal energy, and how might it apply to other places in the world, even outside of Kenya?
Yeah, that's a very good question. I think as Iceland has demonstrated, and as Kenya now is working towards demonstrating, countries that are rich in renewable energy have an incredible economic opportunity in this new world we're creating. I think countries like Brazil that have lots of hydro resources are also trying to leverage this opportunity. And I think other countries will follow in the global south. But Kenya has a leg up because it already has a lot of that electricity capacity built out. And so it can leverage that for industrial processes today. And so I do think that that the opportunity for siting direct air capture in places that have low cost geothermal resources is going to be potentially a very interesting opportunity going forward. Of course, it's not just the energy supply that matters. Yes, as Martin said, it is a very energy intensive thing. You also need to have adequate storage that's going to store that CO2 away. It's expensive enough to capture the CO2 that you don't want any of it leaking out afterwards. That just doesn't make any economic sense to remove it from the air and then have it get away. So there are other components, but assuming you can solve that, I think countries that have geothermal resources are going to potentially see this as an opportunity.
Totally. And if I can just build on that really quickly. So we are really excited about the opportunity for direct air capture for especially the East African Rift Valley, right? So Kenya is very much the sort of focal point of that because it has already built out a lot of geothermal electricity, as Dan touched on. But our vision for the future really is that this is an opportunity that can ripple out north and south across the East African Rift Valley and really bring prosperity in today's new energy paradigm to areas of the world that haven't had an experience of energy abundance yet, right? Places like Rwanda, places like Burundi, places like Tanzania, Uganda, etc., Ethiopia, you name it. And the key opportunity there is to really think about energy in the 21st century as a location-specific opportunity, much like we've done so in the 20th century, right? There is certain economies that made very well out of the energy paradigm of the 20th century, which was fossil fuels. And as we sort of switching towards renewable energy, created from geothermal and clean firm power having a special role for industries like direct air capture, which we can essentially export in the form of direct air capture that's producing carbon removal credits, but also things like sustainable aviation fuels captured from CO2 and other sort of like materials produced from air captured carbon really create a very key opportunity for Kenya to export its renewable energy wealth and actually turn that into like prosperity for its people. That is a big part of our vision, and it's really something that we would like to see be replicated in East African Rift Valley and of course elsewhere too. Generally speaking, we would want to see a shift for again renewable energy towards often sunnier, windier places, as we heard earlier. Many of those are in the global south. So like having that sort of shift of like energy wealth towards the global south and allowing like global south populations to leverage energy prosperity is a really key focus of our technology and really just a stepping stone towards building a more prosperous future for all Kenyans and ultimately for populations beyond that too.
And I think what Martin says is really important to understand. I was referring to the green growth opportunity, but I think it's important for our viewers to really get a sense of what we're talking about. Last year, the world spent about $1.7 trillion in energy investments, and about 2.7 trillion if you include both fossil fuels and renewable energy. That's an extraordinary number. That's a huge amount of money. And going forward over the next decade, if we're going to meet our climate goals, that number has to climb dramatically to 3, 4, 5, $6 trillion a year. But let me put that in perspective. over the last 5 years, less than $10 billion, a tiny, tiny fraction, was actually spent in Africa. So that has to change. But, energy is expensive. So when we talk about building like say a geothermal plant, not even a direct air capture plant, but actually developing with outside investors because they see this opportunity in Kenya, in other places in the world, an investment in Burundi. Burundi is right now the second poorest country in the world, second only to South Sudan. If you actually went in and built a $1 billion geothermal plant, which, by the way, is a tiny energy plant. A $1 billion plant in the US is nothing. And yet in Burundi, it would be completely transformative. It would absolutely change the economy. And so, we have to get a sense of how big a deal this is. The opportunity for outside investment, it's not going to come, the Burundi economy can't do this by itself. And so the opportunity for bringing outside investment into these countries is in some ways the most exciting opportunity in economic development. Forget the climate change part, just economic development. This is unbelievably important and exciting.
Great. Thank you both so much for your perspectives on that important topic. Perhaps this is a great time to kind of shift towards, what you see going forward, and what is the future for DAC? So I'd love to hear from you first, Dan. As we look towards the future, how do you see DAC technologies developing over the next decade, and what role will Octavia play in it?
Well, I think we're, again, as I said earlier, we're at the early stages of technological development. And what that means to me is that I want to see a whole bunch of different projects get started, different approaches, different technologies. We know that at small scale, it's going to be expensive because you get efficiencies as you get to larger scale. And, we're seeing a few examples of larger industrial scales in, frankly, the richer countries of the world. But I think what's really important right now is to see different entrepreneurs, different engineers figuring out different approaches and trying them out. As I say, we need to break some eggs to see what happens here. And in that process over the next decade, it's only through trying these out that we're going to figure out what the problems are and also what the opportunities are. And I suspect we're going to learn an enormous amount. We're going to learn an enormous amount from these experiments.
Thanks, Dan. And Martin, how about from your perspective, what role do you see DAC playing in the future, and where does Octavia fit into that?
No, it's a really exciting question. And the one thing I'll start with is we're not slowing down. 2 years ago, we were 3 people. 1 year ago, we were 20. Now we're 60. And so the goal really is to really use Kenya's sort of ingenious talent pool and natural resources to really drive innovation in the direct air capture space. And for one, we do that by deploying and deploying. Again, as Dan said, a lot of the technological learnings really only come once you actually deploy at scale. So we're expecting to become the world's second to put CO2 into geological storage later this year. And from there, the goal is really to scale up very soon to 1 million ton per year scale. We're hoping and planning to get there around 2030. And from there, really, the cost of their air capture is something that we believe and have very, very much modeled in detail. Those costs can fall dramatically. And once that happens, a lot becomes possible, because ultimately the one thing that we're missing most often in the fight against climate change is hope, because there's so many elements of climate that are just really hard to address. So many emissions that are hard to solve, our flight emissions, or some of our food emissions, and so on. And really, the air capture just becomes a way for creating hope for hard to abate sectors, basically, right? Because some emissions are just going to be intrinsically hard to abate. And the air capture, for its unique scalability and quality, can really just provide us a tool that humanity very much needs in the fight against the climate crisis. And our goal really is to make Kenya the centerpiece of that, to really show the world that not just can Africans build the future, but we can excel and provide a service to the world that it very much, very much needs. And that is low cost air capture at scale. That's the vision.
Excellent. Thank you, Martin. It's very inspiring. And with that, I want to congratulate you and your team for being one of this year's winners. And final question for you, Martin, what impact will this award from Climate Vault and the Tech Chamber have on you?
No, a fantastic impact. And we're really excited by Climate Vault's impressive network of corporate partners and are hoping to, again, contribute to their climate strategies in the nearer future and really just to leverage the momentum that this award also gives us to really bring our stage to market and mobilize catalytic early demand, which direct air capture definitely needs to be proven in the field and taken to scale. And for that, Climate Vault has been an amazing partner, and we're very much looking forward to working with you more towards bringing exciting new carbon removal solutions to the world.
Likewise, thanks, Martin. I know we're looking forward to working with you as well. On that note, I'd like to bring today's discussion to a close. So thank you both so much for your time. Dan, congratulations to you and to the Tech Chamber, and Martin, to you and the Octavia Carbon team for this incredible achievement and milestone. For our audience, be sure to check out last week's CDR webinar, now available on demand, where we spoke with Ning Zhang from Carbon Lockdown, the second winner of Climate Vault's RFP round, and Professor Steve Pacala from the Climate Vault Tech Chamber. If you want to learn more about Octavia Carbon and the Climate Vault approach, check out the following link. Thanks for watching.